Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 13.4, Problem 19. This is Section 13.4, it's problem number 19. It says, draw the graph of the function f of x equals x to the fourth power minus 2x squared plus 1, and be sure to label the x and y coordinates of any critical points. So, the first step is to find the derivative. So f prime of x equals, the first piece of my function x to the fourth has a derivative of 4x cubed. And again, the reason why is the exponent of 4 comes down times the number in front, which isn't written, but it's understood to be 1. So the 4 times 1 gives me 4. The exponent drops by 1 from the fourth power down to the third power. The next piece, the minus 2x squared, has a derivative of minus 4x to the first. And again, the reason is the exponent of 2 comes down times the number in front, which is also 2. 2 times minus 2 is negative 4. X to 1 less power. Second power drops to the first power. The 1 on the end, it has no x with it, so its derivative is 0. So we have the f prime. F prime of x is 4x cubed minus 4x to the first. So step 2 of this process is set it equal to 0. So 4x cubed minus 4x to the first equals 0. Step 3, solve for x. So since I have an exponent, I have to solve by factoring. Both pieces have a 4, so I can factor that out. Both pieces have an x. So I can do 4x, leave some parentheses, equals 0. So 4x times what makes a 4x cubed is times x squared. And then 4x times what makes a minus 4x? Well, times minus 1. So I factored it. But I can factor it down a little further. That x squared minus 1, if you notice, is a difference of squares. So I can break that up a little bit more. So the 4x stays in front. And I'm going to break up my difference of squares, x plus 1 minus 1. And again, you can check it. If you FOIL that out, you'll get back what was in the parentheses in the line above it. So now, 3 factors, 3 answers. The 4x out in front of everything gives me a solution of x equals 0. If x is 0, the equation is true. 0 equals 0. The next set of parentheses here, x plus 1, gives me a solution of x equals negative 1. Again, if x is negative 1, you'll get 0 equals 0. And the last factor of x minus 1 gives me a third solution of x equals positive 1. So this function has 3 critical points. One when x is 0, one when x is negative 1, and the last one when x is positive 1. So we have to find the y coordinate for all 3 of these points. So let's start with the x is 0. Put that into f of x. So f of 0, the x to the fourth will be 0 to the fourth. The minus 2x squared will be minus 2 times 0 squared. And the plus 1 is just on the end. So because of the zeros, it's very easy. It comes out to 1. 0 to the fourth and minus 2 times 0 to the second just kind of drop out of it. So I have a critical point with an x coordinate of 0 and a y coordinate of 1. So we can actually go ahead and plot that on the graph. Over 0, up 1. Be right there. Over 0, up 1. Now, see what happens when I put in an x value of minus 1. Let's find the y that goes with that. So let's put in negative 1 for x into my function. So f of negative 1 equals, the x to the fourth becomes negative 1 to the fourth. Minus 2 times x squared is minus 2 times negative 1 squared, then plus 1. So negative 1 to the fourth, because it's an even power, is positive 1. All my negatives cancel. And the next piece, minus 2 times minus 1 squared. The minus 1 squared is positive 1, but times the minus 2 in front is minus 2. And I have a plus 1 at the end. So if I combine all those, I get 0. I have 2 positive 1s, which is positive 2, and a negative 2, positive 2, negative 2. The y value I get out is 0. So I have another critical point at negative 1 for the x value, 0 for the y value. I put in a negative 1, I got out a 0. Let's put that on the graph. So over negative 1, up 0. This over negative 1 up 0. And I have even another critical point when x is positive 1. So put positive 1 into f of x and see what we get for a y value. So f of positive 1 equals x to the 4th becomes 1 to the 4th. Minus 2 times x squared becomes minus 2 times 1 squared. And then plus 1 on the end. So if you do the math, it's going to come out to 0 also. 1 to the 4th, 1 times 1 times 1 times 1 again. That's 1. Then minus 2 times 1 squared. The 1 squared is 1 times minus 2 in front is negative 2. I have a plus 1 on the end. Again, if I combine my positives and negatives, positive 1 and positive 1 is positive 2. So I have positive 2, negative 2. I get a 0. So my last critical point is it has an x value of positive 1 and a y value of 0. So let's put that on the graph. So the x is positive 1, the y is 0. Now again, I know they're connected. This has a flat spot here. It comes out, flattens up here, at over 0 up 1, comes down and flattens out again. Now because this is sort of a weird function, that 4th power is pretty big, at negative 1 up 0 could flatten out and go up, or it could flatten out and keep coming down. Same thing at the 1, 0. So what I'm going to do is go over to the next x value, put it in for my f of x, and see where the height comes out to, a little above or a little below the critical point that it's near. So let's try f of minus 2 and see what type of height I get. So f of minus 2 equals, my x to the 4th will be minus 2 to the 4th. Minus 2 times x squared is minus 2 times minus 2 squared plus 1. So negative 2 to the 4th power. Negative 2 times negative 2 times negative 2 times the 4th negative 2. The negatives all cancel. 4 2's multiplied together. That's going to be 16. The next piece, minus 2 times minus 2 squared. So minus 2 squared is positive 4, and then times the minus 2 in front. So positive 4 times minus 2 is negative 8, and then I have plus 1. So if I put my positives together, positive 16, positive 1, I have 17. 17 minus 8 is 9. Or you could just do 16 minus 8 is 8. 8 and 1 more is 9. However you do it, you get 9, positive 9. So if I go back 2 for my x, my y that would go with it is 9. So it does turn around and come up. And it'll start coming up pretty fast to go through that. So that's what happens on the left end of my graph. Let's see what happens when I put in a positive 2 for x and what my height will be relative to my critical value that I'm right next to. It's going to be a little above or a little below. So put in the 2 for x, see what happens. F of 2 equals x to the 4th is 2 to the 4th. Minus 2x squared is minus 2 times 2 squared. And then plus 1. So 2 to the 4th, again, 4 2's multiplied together. 2 times 2 is 4, times the third 2 is 8, times the fourth 2 is 16. So 2 to the 4th is 16. Then the next piece, minus 2 times 2 squared. So again, you have to do the second power first. 2 squared is 4, times the minus 2 in front. 4 times minus 2 is minus 8. You have plus 1 on the end. Well, the positive 2 is giving me the same result as the negative 2 did. And the reason why is the exponents are even. Positives and negatives don't matter. This is also giving me a 9. So if I put in positive 2 for x, the y that I get is 9. It's pretty symmetrical. So it does flatten out here, and then it turns around and comes up, up, up. So the final graph is essentially a big giant W.